Welcome to Chris BI. My name is Chris Wagner, and today we're going to be talking about how you create joins between tables in SQL. Before we head over to my desktop and go over creating joins, I want you to like the video, subscribe to the channel, leave a comment down below. Heck, share this with your friends and family. Let them know about how easy it is to work with SQL if you just follow these simple steps, all right? Really helps the channel, helps feed the machine and the logarithm that sends users this way, but I would really appreciate it if you did that. All right. So the whole concept of querying a database, and the reason why we use relational databases is so that we can relate one table to another table. All right. Now we do that with the concept of a join. Like how do these join together, right? What do we do to make these join? And there's several different types of joins that exist inside of a database. The first one is being an inner join, and that inner join says where you'll give me the values where table A equals table B along this field, right? And we've got an illustration here for you to look at, right? And there's a left join, right? A left join says, give me all the values from table A and give me those values that match along a certain condition from table B. All right. And then there's the final type, and that's the right join. And that's from give me the values from table A that match to all of the values in table B, right? And give me that. Now, so it's kind of like the reverse of a left join. I'm going to say that, inner join, left join, and right join are the most basic ones. There's some other ones that are out there, but for the basics, these are the three that you should know about. And in fact, while there's three that you should know about, there's really only two that you should, know, love, and get into, and that's the inner join and the left join. I mean, even just by looking at the diagram, you can see the left and the right join is really just in the order in which you create you bring your tables together. So let's kind of go over how we can do this. So let's go down to my desktop. All right. So here we are. We've got our AdventureWorks database. We're going to start a new query, and we're going to look at some of the tables that are inside of our query. Now, as you can remember, we always want to start with select top 1000 star. This ensures that I'm getting my top 1000 records back. But I really, I kind of don't care about that statement. I put it there just so it, the query parses out as I start to write it. But I'm going to say from. And now the order that you write the tables is very important. And in a data warehouse, you're going to have really two different types of tables. There's going to be fact tables, which are going to contain your values and the information, like your sales amounts or your order quantity, that type of thing. And then there's going to be dimensions, and the dimensions are going to be descriptive, the descriptive attributes that go along with your query. Now, in this case, I'm going to recommend that you always start with a fact table as your base table that you write your query from. Okay, now there might be some situations where you start with a dimension. Few and far between. Don't pay attention to those for now. Start with your fact tables. So in this case, I'm going to start with my fact table for internet sales. So I'm going to bring over my fact table from internet sales. I'm going to alias this as FIS, so it's fact internet sales, right? And now, looking at the fact internet sales, and I want to take a look, so I'm going to expand this so I can see what's inside here. I'm going to want to join to my date field based upon my order date key. So here is where I'm going to create my inner join. Inner join. Right. And I'm going to drag in my date table. And I'm going to give it an alias on it. I'm going to say DD. And here's another place where we're always recommending good use of white space, right? So I defined a table. I then put a white space. I did a carriage return here. I then define what inner join table is going to join. But now it's super important that I define what is it going to join on. So I alias my date dim with DD, and then I want to say it's on. So what am I joining this on? And always maintaining good white space. So I have my from table, my carriage return, and then my table that I'm going to join on. And then I say on FIS, because I always want to start from and I want to work my way back. FIS, and then I'd order date key, right? Equals, and do DD dot date key. Now, Chris, you say, hey, there's the order date key, but there's also order date, and then there's actual dates inside the date field. Why did you join on the keys? So that's a great question, and you should want to know that, right? When you write a query, uh, your queries will run much better and much faster if you're always joining upon integers. Integers are the most basic form of seek that a database can do. So when you join on an integer, it is the most basic and fastest join. I believe it goes integer, generally speaking, integer, date, and then like all like and varchars, right, or characters and that stuff. Characters always having significantly more overhead on them, and really when you compare an integer and a date, in small databases, not a big deal, but don't presume that you are always in a small database. Presume you're in a big database and the performance is important. So start with the keys, and integers. You can't go wrong. All right. So I've set this all together. I want to run this and test this out. I do F5, and now I can see that I am getting all of the values from my FIS table, which is right here, product key, order date key, due date, right, ship date, blah, 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 all the way down to ship date time, right, ship date, right, so that's here. And now we go through, because I did star, we get all the values uh, from my date dimension, right? So good so far. Right, this looks right. We're good to go here. This would be an inner join. Now, we might also want to do a left join. Now remember that the left join is going to give me all the values in fact internet sales, or table A, and then the values that exist in table B that relate to that factor net sales. And so in this case, we're going to be doing the customer. Okay. So dim customer, DC, right, for dim customer, DC is my alias on. And again, FIS dot customer key equals DC dot customer key. All right. Now I hit F5, and I'm going to get all of my products again over to my ship date. Then I'm going to get all my date fields until I hit my customer table. And then I'm going to get all the values from my customer table. Now, let's say I want to do something along the lines of I want to limit down the values of the customers that I pulled back, but I want to see all of the values that I'm getting. I don't want to lose any of my fact table values, right? So, but I really only care about information uh, on on customers with a graduate degree, right? So, if you remember back from the previous video in the where, you could actually establish a where clause. I could say where, and then I could put in this value. Like I could say where DC dot English education equals graduate degree. Oh, graduate degree. Now, if I run this, I'm going to notice something odd in that I'm getting only the people that have a graduate degree, but I really wanted all of the values from the fact internet sales. I just only cared about the customers. Like I only wanted to see the details on the customers where they have a graduate key. And this is where you can actually get kind of sneaky, is you can actually move, instead of a where clause, you can put this inside of your join condition and say, and DC English education is graduate degree. So I then hit F5. I can scroll over and I can now see that while I normally see all of my customers, right, all the customer details, now I only see customer details on the people who have graduate degrees, and I don't see any of the other values, okay? This can be a great way of understanding, what's going on in your database. It can also be a real good way in increasing the performance of your queries, right? So in this case, I still have everything from these base tables because this is a left join, and so I'm getting everything in Vector Internet Sales that has a value inside of the date key on the order date. And then only finding customers that have a graduate degree. If I change this left, though, to an inner, I'm going to do the exact same thing that having this value in the where clause does, except for it will be much more performant because my query optimizer, when it goes to evaluating my my query, it's going to take into account everything that's in the from statement before it moves on to the where statement. Again, because this is a small database, this took like literally less than a second to return the value, so it does not matter. But there's many of you that are going to be working in exceedingly large, databases with terabytes of data. Understanding that putting your limit inside of a join can really help in your performance and help make your things run faster. One of the big things I highly recommend, and we're gonna kind of cheat on something here. I'm gonna comment this out, is when you start writing these joins, and I'm gonna make this one left again. When you start writing these joins, you want to make sure that you're not creating problems inside your data set. For example, if you're starting with the customer table and you're doing joins, you don't want to do something. You want to join to something that duplicates records or makes your or inadvertently reduces records, where it shouldn't, right? Like in the case of joining on date dimension, I shouldn't have lost any records when I did this. Otherwise, there might be an issue with my data that might necessitate doing a left join on my date dimension. So a quick and easy way that I do when it comes to building out my queries and to test to make sure that I'm not losing any information is I put this as kind of a standard at the top of all of my queries I build out is the select count star 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 CNT at the in commented out right above my from statement. What this does is allows me to highlight my base query, hit F5, I run, and I see that it's 60,000, right? So as I'm testing this out, I can track that this was 63,000. The value here was 63,000. Now I can select my next join inside here. I can hit F5 and I can ensure that I'm getting the exact same value here. If I'm not getting the exact same value on a join, that's indicative of there being something potentially amiss in my data, right? So, if my date dimension didn't join up to on the order date key, It might be that there's some orders without an order date, and I might be missing. So that would indicate that I need to go over to a left join, right? I can do the same thing now when I come down to my next join. I hit F5. Again, I see that I am still getting my 63,000 or 60,000 records here. So that is generally speaking really good. So it means I've done this right. But if I change this to inner, right? So now I'm only going to get values that where a customer has a graduate degree. That's at least that's what I'm expecting, right? So this number should be much lower now, right? F5. Oh, yep. Look, only 1/6 of the values basically are customers who just have a graduate degree. So this makes it really easy for me to track. By doing this, I can ensure that I'm not losing records where I'm not expecting to lose records. I'm not actually duplicating records or causing any problems. Generally speaking, though, I would expect that, especially when I think about the tables I'm joining, like to a date, that this number shouldn't change. But when I join to a customer table, I'm going to expect that this number, because it's an inner join, it is going to go down. Now, one of the things I might do just to double check that this is going down appropriately is I might make this a left join, right, to ensure that I still maintain this 60,398 records. Now, I already know I do, um, but especially when you join to something like a customer table where there's all sorts of weird things, and it might not be super straightforward as to what the joining key is. You may want to make your join a left join for your initial select count estimate to make sure that this number doesn't go up. If that number goes up, you have your join wrong, and you're going to be duplicating data and getting the wrong information. Okay. Now, uh, I do recommend that when you write your queries, you start with your inner joins at the top and you organize them so that your left joins are at the bottom. Again, the reason being for validation's sake, it's really easy to run through right at the top, baseline, see how many records you have, go to the next query, making sure that you're not losing any records, or if you are losing records, it's understandable, and as especially, and then work your way down to the bottom, testing that out. Organizing your query can be really helpful, not just as you write your query, but as you look at how you troubleshoot down the road. Okay. All right. Thank you guys very much. I hope you found uh, this session on how you write queries and how you create joins between tables useful. This is a big topic. This is something that you could, leverage and do or you could do this in many different ways. You could leverage this to perform insanely complex analysis. It is it it is the foundation of relational databases, which is creating these joins. So I hope you understood this. I hope this made sense. If not, rewatch it or leave a comment down below. Let me know what you think. Love to hear from you. Love to hear what other items you want to learn about when it comes to writing queries. Happy to create some additional content on that. Again, hit that like button, subscribe to the channel if you can, or haven't already. Thank you guys very much. You guys have an excellent day. Peace.